cover off your homework. It's gonna be tough to read up there, but I'm gonna kind of just read it out to you real quick. It says a production of 2 certain products. Doesn't even tell what the products are, right? So it's probably gonna label one with A or B. And when you get to college math, they're gonna think of like thingamajigs or Ujima flips. They're just not gonna name the product. But we know we're making 2 things. And here's what it requires, right? In order to make this, you need unskilled labor. That would be the type of labor I do, right? Anyone can do it. You don't get paid much, right? Skilled labor, right? That would be like Andreas, who's very efficient in everything that he does, gets paid more than me. And the machine time. So you have to pay for this machine time. You have to use a certain amount of machine time, but you're not allowed to go over, all right? So when you make these products, all 3 things are required, right? And if the product takes too much machine time, you can't make it. So this is a constraint because it limits how many you can make. All right. The company has 2,007 hours of unskilled labor. So that tells you how much of one resource it can use. Right? It's got 1,500 of machine time. That's how much machine time. That's how much of that resource we have. And it's got 700 hours of skilled labor. All right? Every week. All right? You can make product A, and it tells you how much it needs. Product A requires 1 hour of unskilled, 3 machine times, and 1 hour of skilled labor. Right? Product B requires 6 hours of unskilled. I make a lot of those. 1 machine time and 1 hour of skilled labor. If the company makes $50 profit, we're talking about profit from each product A and 55 from product B, right? How many of each product could be maximized? How much should we make to maximize our profit is what it's saying. Is that okay so far? So we're going to call X what? Product A. We'll say amount or number of, right? Product A. And this would make Y the number of, yes, product B. And you know the easiest thing on here is the objective function. That's our objective. What do we want to do in this case? We either probably want to make money or limit costs, right? So in this case, we want to make money. We want to have a profit. How do I figure out my profit? What is it? Say again?
50x plus 55y.
Dolores says 50x, which is how much? What is this?
Profit.
That's the profit for every of the product A, right? Plus 55y. That's the profit for every product B, right? Do we know how much we're going to make yet? No, but we know how much we can sell them for, or at least not how much we sell, but how much our profit when we're done selling. Is that cool so far? All right. So what we need to do is we need to come up with constraints, all right? And we're limited in 3 things. So one of our constraints is that we only have 15,000 hours of machine time. Oh, nope, that's unskilled labor. Can I go over that? No, because that's all you have, right? So we know that our unskilled labor can't go over that. So
Machine time.
is that machine time?
Unskilled labor is 2,700.
Let's go to unskilled labor. Which one's first? Unskilled labor, 2,700. Thank you for staying on me. Unskilled labor is 2,700. I can't go over that. Can I go up to that?
Yeah.
So what am I going to add to this inequality sign? An equal sign, right? And we only have 2 products that we're talking about that require unskilled labor. So what's this going to be? How are we going to figure out that constraint? Is it x plus y?
Wouldn't it be?
Say again. Go ahead.
Well, no, it's just hours. So wouldn't it just be A plus 6B? Wait.
So Max says that the x right here, right? X
Or A plus y.
is 1 hour of unskilled labor.
X
Right.
plus 6Y.
And then the second product, y, right, requires 6 hours of unskilled labor. All right? So for every one of these I make, that's how much unskilled labor it requires. All right?
Why is it 6Y?
Well, if you look, why is it 6y? Because product B requires 6 hours of unskilled labor. So for every one of these I make, that's 6 hours required. Now, is that okay? So I've just turned that into a constraint. How do I solve this? Minus x, so we got 6y is less or equal to negative x plus 2,700, and then what do I do? Divide both sides by 6. Dolores, I'm going to count on you for your math there. That's negative 16x plus 450. Thank you, ma'am. And there's one of our constraints. Easy or hard? Easy? Is that okay? So let's talk about, we've done unskilled labor, right? Well, I'll put a little unskilled labor. Let's talk about machine time, right? So we're going down here to machine time. And how much machine time is available?
1,500 hours.
Everyone see it's 1,500? So I write 1,500 right here. And I can't go over to it, so what's my inequality sign?
Less than or equal to.
Less than or equal to, because I can't go over it. All right? Jacob, what's the equation that I'm using here? My inequality is what?
Y is less than or equal to negative 1 6x plus 450.
That is the last one, right? But how do I do this one based on machine time? Right? That's my total amount of machine time. So product A requires how much machine time? The first product requires how much machine time?
3 hours.
3 hours. So what would I write here if my first product is X?
3x.
That is turning that into machine time, right?
Yeah.
That's saying, hey, this isn't just a number, but how much machine time each one needs and that variable, right?
Yeah.
And how many Y's?
1. So it's
One Y. Do you guys agree on this? Everyone's good on this? So if I solve for Y, what do I get? I get Y is less than or equal to
negative 3x.
negative 3x plus 1,500. And I'm done, right? There's my next constraint based on machine time. Well, I've done unskilled labor. I've done machine time. Now I'm going to do skilled labor. I'm just going to put a little SL. Skilled labor, how much do I have? 700. And each one only takes how much skilled labor?
1 hour.
1 hour. So all we have to put here is what? Right? 1x plus 1y is 700. What do I do? Subtract x and I get y is less than or equal to negative x plus 700 in this case. All right. So there it is. I've got all of my constraints. Our goal is to now graph these. I'm going to pause this really quick. All right. I'm going to pause this. All right. Here we have it graphed out, you guys. And Dolores did an awesome job here. She's got everything color coordinated, which is a good for some of you guys to see. I do things with arrows because I'm just not as efficient or as you know, color oriented, I guess. But this is beautiful. This is one of the ways we talked about graphing things yesterday. And if you look at it, she's got all our constraints up here, and you can see them, right? So here's one of the constraints. Y is less than or equal to negative 16 plus 450, which is this one right here. Where is my 450? Is it this one here? All right. And we can see that it's going down, and you're shading down in that case, right? The other one is y is less than or equal to negative 3x plus 1,500. That's this one. And what's a really good way to, a good way to graph these guys is by using, we could do slope, but when your number's so big, it's hard to see. So, can you do the scale factor? Yeah, but sometimes you're going through so many hexes, right, or squares that it's hard to do. You can graph by x and y intercepts. How do I get my x-intercept? I let y equals 0, and how do I get my y-intercept? I let x equals 0. So I can take those equations and graph my y-intercept and my x-intercepts, and it's gonna help you. All right. And we can see the last one is negative x plus 700 is this one right here, and all of them are shaded down, right? So we get this region at the bottom here, in which kind of utilizes the graphs. All three graphs overlap in this region, and we have, it looks like 1, 2, 3, 4, 5 vertices. All right, does everyone see that? That's where the regions, we've got one here, right? That one here, she has listed as 500 and 0, right? We've got this one right here. This one here, she found out where they intersect is 300 and 400, all right? This one right here is 400, 300, right? This guy down here is, this is the 500, 0.
The first one was 0, 450.
That was 0, 450 here, which is right here, all right? And then we've got the 0, 0. So we've got these 5 points that we should plug into our objective function, all right? And our objective function in this case, like we said, was 55x plus 55y. That's our profit. So if you plug those points into, in which case, which one is our maximum on this? Our maximum is 3,700. All right. Does everyone see that? Are there questions on this? So the first thing we do is we figure out our variables, right? After variables, probably the easiest thing to do is to figure out our what? Probably the objective function, right? Sometimes called objective quantity. And then we got to find our formulas for our constraints. And once we find them, we do what with them? Graph them. Make sure we shaded the right way. We're going to find a region where all the graphs do what? All the shading overlaps or intersects, right? And we go around, we figure out our vertices. We write those vertices and plug them into our objective function to maximize or minimize. All right. Is that okay? Do you want to see one more?
Yeah.
Yeah.
All right, let's pause that. And I'm not going to